Welcome back to Understanding Python. My name is Jake, and today I'm going to be covering variables. We'll start simple with variable naming conventions and move towards variable scope. So you can think of variables as containers that store objects or references to other objects. With that out of the way, let's get started. So I've already saved a new file called variables.py in the variables directory under Understanding Python. At the top, as in the previous video, we're just going to put a little doc string. This is variables. And the first thing that we're going to cover is good naming conventions. So we'll say good names. Good names are things like age equal to 42, name is equal to Steve, it's a good name, address, we'll just say 123 Sesame Street. So these are examples of good names. Not only are the variables correct, as in they don't violate any of Python's constraints, but they also describe the contents of the variable. So age refers to a numeric age. Name refers to a string of someone's name, and the address is again a string of someone's address. Likely not an actual address, but I'm not going to go that far. So with good names out of the way, let's look at some bad names. So bad names would be either variables that don't really tell you anything that's going on. So we'll say a is equal to 5. That doesn't really help anyone if they're looking at what a is, especially without any kind of context. You can also have bad names that are just way too long or just run on. So this is my super awesome variable with a long name, and that will equal 17. So that's just straight up awful to look at. It's really hard to read. It's way too long. You definitely don't want to do that. So aside from names that just look bad, that don't give any kind of context as to what's going to be stored in that variable, there are actually some, we'll say, illegal names within Python. And what do I mean by illegal? These are names that if you try to define them in your script, Python will outright refuse to run. These are things that start with numbers. So we'll say 99 red balloons. We'll just assign this to none. Put a little comment here saying can't start with numbers. So say that we understand that you can't put numbers at the front of a variable. Well, if we were to do red balloons but put a dash in it, that would fail as well. So let's try that. Red balloons equal to 99. For this one, we're going to annotate this can't contain dashes. And just like the dashes, if we understand we can't use dashes but we try to use spaces, that's going to give you the same thing. So we can't use spaces. So if we were to save this and try to run it, ipython-i, and this is variables.py. Oh, see, there's our first one, invalid syntax. So if we were to comment this out, save it, move on to the next one, we have our invalid syntax for that variable. Comment that out, move on to the last one. As you can see, that one fails as well. Okay, so with those commented out, we now don't have any issues getting into the file. So keep that in mind. Do not put numbers in front of a variable. Don't put dashes inside of a variable name. And don't put spaces inside of a variable name. Aside from that, you're largely free to do what you want to do. And I believe recently in Python 3, you can actually put emoji in your name if you want. I don't recommend that. I would consider that under the bad names. I'm not even sure how to do emoji on this keyboard, so I'm not going to mess with that. So now that you know what good names are and some examples of bad names as well as illegal names, you've already seen how we assign values to those variables. Especially if you watched my last video, then you saw tons of variable assignments, so I'm not going to go over that again. However, one thing to keep in mind is that you can switch what a variable stores at any time. So we'll annotate this variable switching. Sure. So first we'll start off with hungry being equal to true. Now say that we ate something later on in our code, we can set hungry equal to false. And now hungry, which was previously true, is now equal to false. And you don't have to worry about switching between different types, as Python handles that flawlessly, because it is what's called a dynamically typed language instead of a statically typed language. With statically typed language, you set what the type of a variable should be ahead of time, and then it's locked into that. With dynamically typed languages, you can make these values anything that you want. So we'll call this section here dynamic typing. And we'll set hungry equal to 7, of course, which makes sense. And we'll also set hungry later on, overriding it with something that makes a little bit more sense. I am not currently hungry. Perfect. The next thing to note is that since almost everything in Python is an object, you can even store references to functions or classes in a variable. So we'll call this section nicknaming. So what we can do is we can create a new variable called yell, which simply points to the print method. So this isn't actually us calling print, this is just referring to the print method itself. So now we can use yell as we would normally use print. So for example, if we're to yell hello world, it's going to work perfectly fine. So let's save this and see what that looks like. Go into IPython and we see hello world. We can also yell hungry, just for the fun of it. So exit, reload in, hello world, I am not currently hungry. Beautiful. So the last thing I want to cover in this video is something that's a bit more complicated, and this comes into scope within Python. So what do I mean by scope? So in Python there are different levels of scope, or where a variable can either be accessed or modified. At the very top level, or the global level, is global scope. So in this file, global scope is what we're currently working in. So I'll make a new overtly global variable called my age. We'll set that equal to 33. Now, if we wanted to make a function that would change the age or attempt to change the age, we can see what this would do. So we'll call this one def no change, maybe a bit of foreshadowing. We're going to set my age is equal to 45. Not very flattering, but we'll see what happens. And then we're going to print age after, put a space in there, and then a comma, so we can then set the value that we're going to be printing after that equal to my age. Alright, so let's go ahead and save this. Open this interactively. We see our hello world and I'm not hungry. So let's go ahead and check out the value of my age. So my age currently says it's 33. But what if we were to call no change? Inside no change it says age after is 45. But let's take a look. Oh, my age is 33. The reason why this happens is that my age is a global scoped variable. Inside this function, it's actually not able to modify the value of my age unless we explicitly allow it to. So in here, within the scope of this function, it sets my age locally to 45, prints it out, and once you're out of the scope of the function, or after the function's done being called, we can see that my age reverts back to 33. Now what if we actually wanted no change to modify my age? Let's go ahead and copy this. So instead of no change, we'll call this one yes change. And in here, we're going to set a keyword, a new keyword, global, and we're going to say global my age. This is effectively giving permission for this function to be able to modify the my age variable even at this local level. Now, since I know this is going to stick, let's just go ahead and decrease my age by 4 years. Let's save that, run the file, check on my age. Check on my age, currently 33. Let's run yes change. It says age after is 29. Well, I quite like that. Let's go ahead and check. My age is now 29. Thank you, yes change. Okay, now we know what global scope is, and if you have any questions on that, please feel free to leave a comment down below and I will do my best to answer the question to the best of my ability. So the next example I'm going to give you is something that you're not going to see as commonly as global, but it's still very important and something that you need to keep in mind and you'll probably run into in the future. And if you don't retain this, you might think I might have a bug in my code. Well, outside of global scope, there's also different levels of local scope. What do I mean by that? Well, let's just go ahead and define a new function. This one is going to be called no outer change. Again, might be foreshadowing here. And in here we're going to make a new variable called outvar. We'll call it outervar. And set this equal to astronaut. Then we're going to make a function inside of this outer function. Don't worry about this too much right now. I'll cover this in a future video. Just follow the flow of what's going on at this point. Outervar in here is going to equal to fire truck. And this will make sense in a minute. Get rid of that extra front space. And then we're going to set an inner var equal to spy. In here, we're going to print I wanted to be a, put a space, a comma for our value, outervar. And then, since we've escaped the scope of this inner, we're actually going to call it within the scope of this outer function. So much like we did down here where we called yesChange when we were outside of the yesChange function, we need to do the same here so that this method right here actually gets ran. So we're going to call inner, and then down here we're going to say print most kids wanted to be a firefighter. We'll put a period there just for good measure. And then down here we're going to say print, but I wanted to be a, or n, the space, and then outer var. And just for completeness sake, and this will give us an error initially, but we'll work around that. We'll say print, but being a, with a space, comma, inner var. Notice how I didn't even want to complete that. With a space, could be cool. Now right away, my editor is giving me a warning. Undefined variable inner var, but I've already defined that up there. Now of course I know that this is going to fail because of this, but let's watch it fail. So if we go up here on ipython-i, and then we're going to call no outChange. Oof. Name inner var is not defined. But why? I defined it up here. Why can't I reference it down here? Well, that's because inner var only lives within the context or the scope of this inner function. As soon as you're out of it, it goes away. We want to continue this example, so what we can do when we know something probably isn't going to work is wrap this in a try and accept statement. We're going to cover try and accepts more later, but for now, let me type this out. That is too secret for me. But for now, whenever you think something has a good chance of failing, you can put it within a try block, and if it encounters an exception, in this case the exception was name error, you can catch that and then do something specific for it. So let's go ahead and save that, reload the file, call no outChange again, and see what happens. Here we have, I want it to be a fire truck. Most kids want it to be a firefighter, but I want it to be an astronaut. Finally, we have too secret for me. So what's going on with this? Well, we have this statement, I want it to be a fire truck. That's from the inner function. Well, that's because in this, the first thing that we did was defined the outer var. Then we defined our function. We haven't run it at this point, so print doesn't actually run at this time. It isn't until line 47 here that the inner function is called, and then we enter the scope here, and then we print the outer var, which is local to the inner function. It continues on outside of here. Most kids wanted to be a firefighter, but I wanted to be a, and we see it says astronaut. Just like with our global example, the change to outer var did not escape the scope of inner. So how can we change this? And of course, you know that we can. Let's go ahead and copy this because I'm lazy. Well, for this, we have another keyword that we can use. This one is going to be nonlocal. Outer var. So we'll save that and change this to yes, I'll change. So non-local works a lot like the global keyword does. The difference being that it lets you escape out of an inner context into an outer context without that outer context being at the global level. So this is handy when you have nested methods like this, or nested functions, and some other use cases that we're not going to get into today. But that is most of what you need to know about non-local. Okay, so throughout this video you've seen me write variables in different ways. We have variables that look like that, variables that look like this, and so on and so forth. So I'm actually going to add a new section up here above variable switching. We'll call this recommended patterns. So these are recommended patterns for different types of variable naming styles. So the first one, just all lowercase, we'll just call this one normal, and just say it's a normal variable. Now if you have multiple words, it's recommended that you separate your words with an underscore. Multiple words. And we'll say separate words with an underscore. This helps to make it more readable, so it's like you have a space there without violating Python and actually putting a space. Sometimes you'll see people using variables that look like this, multiple words, but I don't recommend that. It's much clearer to use the underscore. For classes, it's really common to see what is known as camel casing. So we'll say my class name, and we'll set this equal to use camel casing for class names. The reason why they call it camel casing is because the variables go up like it has humps. For global variables, it's nice to make everything uppercase. So we'll call this global variable. Set it equal to use all caps for global variables. That makes it easier for people reading through your code to understand where a global variable exists, and will help you later on to determine if you actually need to add in this global keyword if modifying a particular value doesn't seem to work. Much like global variables, it's also nice to add constants in all caps. So constants in Python aren't truly constant. You can modify these at any time, which is why it's nice to annotate this by making everything uppercase, so you let yourself and other users in your code know not to modify the value. So we'll say constants should also be capitalized. That wraps up this video. Today's code will be added to the Understanding GitHub repo, so check the description for a link. As always, if you have any questions or suggestions for topics you'd like me to cover, please leave a comment down below. To keep up with this series, please consider subscribing. Thanks for watching.